What I've put together here is some visual assistance with the lesson that we're going over right now in Chapter 4, which is your ability to prove two triangles are congruent. This is from Mr. Thomas's third period geometry. Now, with putting together a two-column proof, you have to be able to identify both your statements and your reasons for that particular proof. Some of the reasons that you're going to be using are going to be visually identified. The first of them are your given statements. Your given statements are given to you in the proof. So automatically those are going to be the first two lines of your proof. And it is up to you to rewrite them in the T-chart, which I'll be showing in a later video. Your next visually identified reason is a reflexive side. I've given a visual representation of reflexive side. It's a side that shows up in both of your triangles. And being that that particular side is a part of both triangles, it has to be equal to itself. A reflexive side is something that you have to recognize and that you have to be able to put into your proof. It is not something that's given to you. It's not something that's told to you. Reflexive angles, same situation, but an angle. That one particular angle shows up in both of the triangles that you're working with. I've also given a visual representation of that. The last reason that you have to be able to visually recognize is your vertical angles. You'll notice vertical angles because of the bow tie. Again, vertical angles are going to be given to you in the visual representation of the triangles that you're working with, but you will not be told that the angles are vertical. So that is something that you have to recognize yourself. And these are three reasons that you have, or four reasons that you have to either automatically know, or that you have to automatically know for all intents and purposes. Your next set of reasons have to deal with parallel lines. Your alternate interior angles and your corresponding angles. With alternate interior angles, if you're told that two lines are parallel, there's a possibility that one of these two angle relationships is going to be your reason. Actually, it's not a possibility, it's a given. In the example that I'm showing right now, side AB and DC are parallel. And because they are parallel and they share a reflexive side, that means that angle ABD and angle CDB have to be congruent. Again, the information that you're looking for is if you're told that they're parallel, this is going to happen when your top and bottom side are parallel. If your left and right side are parallel, you're still going to get alternate interior angles, but they're going to be two completely different angles. In this case, AD and BC were parallel lines, so that means the angle ADB and angle CBD, angle ADB and angle CBD are going to be congruent angles. For the most part, you're looking for the angles that are created by the reflexive side and the parallel line. You must pay attention to where your vertices are and your second and third point, because those are important when naming your angles. Your other angle relationship that occurs with parallel lines is your corresponding angles. Now this one, it comes up, but it's very rare. In this particular case, you have two parallel lines on two separate triangles that don't have a reflexive side. They have a transversal, which is AD in this case, but they don't have a reflexive side. In this case, the two sides that I wanted to be parallel were AB and CE. And being that those two lines are parallel, that meant the angle BAE and angle CED were going to be congruent automatically. So again, if You're given the information that you have a pair of parallel lines, either alternate interior angles or corresponding angles will be one of your reasons. The last, well, one of your statements. The last of your statements will be things that you need to know the definition for. Things such as midpoints. You have to know what a midpoint does. A midpoint cuts a line segment into two equal line segments. An angle bisector. What does an angle bisector do? An angle bisector cuts an angle into two equal angles. An isosceles triangle. An isosceles triangle has to have two equal sides, and it has to have two equal angles. So those definitions are going to help you when you're putting together your proof also. With following videos, I'll be going through or showing you how to set up an actual proof for a triangle that's given and with the information allotted to you for that particular triangle.